Hi, and welcome to Zojo again. So one of the things I like to do on one of my old tools, Live Code, was edit images with filters, and they had a thing called image data. Well, in Zojo you have a thing called surface, RGB or RGB surface, and so I'm going to show you how you would do that. For complexity, I just stuck a picture into the project here. Normally you would have a user call that up. So I've already added that script to this button. Oops, I don't like it when it does that. Dim as picture equals this image that's here. Okay, and let's go back to this main window. And then I just added an image well because we're just going to show the picture. And I labeled that IW final. So let's go back into this. And let's do what I call convert to luminance, which is a better way to make a really nice grayscale that will be able to convert to and from color to grayscale perfectly. I didn't come up with the algorithm myself. I read about it, and it's a pretty good one. So this will be where we are going to store our picture. So we'll go image equals P. And we can just test this out right now to see if this picture will show up without adding any filters, of course. And sure enough, it will. It doesn't scale on this version of Zojo like it normally does. I could adjust that so it did scale by using a third-party library. So I'm going to add this third-party library here. So I'm going to say me ns image view MBS, and the reason I'm adding this is so then the picture will scale and center like it's supposed to do with an NS image well. It's not doing so right now in Zojo, but and I can hit the tab here, and what I'm looking for is the image scaling. So that will equal. That's one good thing to have a couple plugins that do some things. You can adjust things when the IDE is doing them, not necessarily the way that it is done defaultly by the system. So we're going to scale it proportionally, and then we'll also I'll just copy this. Actually, this might work by itself. Let me see. Oops, did I not stop it? Oops, I didn't stop it. Let me just make sure. Let's see if this works by itself, or it will. There you go, and it scales proportionally. That's what an image well does natively on Xcode when you build with Xcode. Obviously, there are properties, but for some reason, Zojo, it used to do this, and it no longer does it. Don't know why. So that's a quick fix if you have access to MBS. So we're going to do the RGB surface, however. Instead of using a plugin, we're going to do it using RGB surface because it's cross-platform. It works with Linux, it works with Mac, it works with Windows. Some of these plugins, they only work with one or two platforms, and sometimes you need to do something for Linux. So first we're going to start off, if you use live code, this is pretty much done the same way as you would use the image data. It's just called something different, but it's pretty much set up the same way. So first I'm going to declare a couple integers for red, green, and blue, and then I'm going to also have for this one I'm going to have a gray value, and I'm also going to declare y and x for integers too. Okay. We also have to declare a pixel color, so let's just call it pixel color as color. And we also have to declare the RGB surface. So I'm going to call it pick. Let's call it pick RGB, I guess, as red, green, blue surface. And then that will equal our picture up here, p dot. It's easier to type it and look for it. So we declared integer values up here. We declared a color and our surface, our picture surface, which is basically the way it reads the pixel data. So we can go for y equals 0 to p dot height. So we want the picture height -1. So it's going to go through the height and width of the picture, scanning pixel by pixel. And we're going to do for x equals 0 to p dot width, and again -1. And then we're going to close the loops, and then there's going to be a bunch of stuff that's going to happen inside this. So basically now we are going to say our pixel color equals our pick RGB with the property pixel, and then we're going to step the pixels over x, oops, it's actually a small x, x and y. So it's basically going to step through every pixel of the image based upon the height and the width. And then it's going to return a red, a green, and a blue value. And this will be relatively the same. It will be pixel color dot red and pixel color dot green and pixel color, can you guess it? Could it be dot blue? So we're basically taking the colors. And so there we have our data that we can use, and now we want to convert it to Luminance, which sort of does a grayscale image, but it does it in a way that that grayscale image can be converted back to color. And the person I got it from is the guy that made Photoshop. So it's got to be a good algorithm. If it was used by the guy who made the first Photoshop 1.0. So we're going to take gray, and gray will equal red, and I'm looking for my number key here for the little multiplication symbol, and then we're going to put a what they call double or a floating point value in here, and I'm going to look at my notes here to make sure that this particular value is right, because this does have unbelievable results. So we also are going to take green, and we're going to times that by this magic number 0.94, and then we add that value to blue, which we multiply times this last magic number, and bada boom, there we go, that's our luminance. And now what we need to do is we need to, and here I'll write a little note here, add new RGB values to image. So what it will do is we're just going to say, hey, pick red, green, blue dot pixel, and then we're going to say XY again, because it's going to add So what it's doing now, it's going to take what we've, our values here that we have multiplied, and it's going to assign new values for each one of these pixels as it goes over it. So all we have to do is say equals, and we're going to use RGB. You can use some of the other color things that Zojo does, but I like using RGB. And we're just going to keep passing it in gray, gray, gray. And that's pretty much it. So let's try that and let's see if that works. And there you go. You can see it converted to luminance, and let's see what the original picture looked like. Here is what it looks like in the IDE preview, and it converts it to luminance, which gives you this grayscale type effect. And you can do this with a number of different things. Like, okay, so the same setup can be used for multiple types of filters, and just to prove it, I'm just going to, actually what I should do is just copy this button and make a new button down here. We'll call it something else like, let's call it negative. Let's just call it neg. So don't worry about the spelling of something. And we can do another filter pretty much using the same setup we have, except for we are this time going to use red, green, and blue. So basically we're going to, a negative, like a color negative or even a grayscale negative. So basically what we're going to do is we are going to invert the image. So what we need to do is up here, I like to do it like this. So I'm going to add some new integers. I'm going to use R2, like R2D2, G2, and B2. And all I'm going to do is put R2 equals, and let me put them all in here so you can kind of understand what's going on. G2 equals, and when I put these parentheses, that's it's a good way to do math. Is to do math between these brackets. Okay, oops, I forgot the equal sign. That's not good. And then down here, we're going to do this again. R2, which will be the first value. G2 and B2. You can get a lot of these algorithms through online. There's a lot of books that do image algorithms. There's some very good books. A lot of them are really expensive, so I suggest going to your public libraries and checking out image processing. Actually, it's more like image algorithms is basically what you have to look for, is algorithms or anything in computer science to do with math or image processing, and you can get any of these values. So what we're going to do is we're going to invert the image. So all we're going to do is take 255 and we're going to subtract it by the pixel, the red pixels that we get up here, red, and then we're going to subtract it by green and by blue, and that'll give us a negative. Pretty simple, right? And see, the best part about this is this works with any platform that Zojo supports. You don't need any fancy plugins. And like I said, a lot of these plugins, they don't work with Linux, and that's a real big problem, because I like to work with Linux. If it doesn't work with Linux, that's a problem. But you can use RGB surface and not a problem at all. So let's see what this looks like. This should be it. And there you go. It gives me a color negative. Again, here is the luminance one. And actually, we could do a luminance one and then apply that same filter to this, which would give us a negative for that. So, and basically it just did that. And you want to know why it just did that? is because we are referencing the same picture. So there you go. I showed you 2 ways to use RGB surface. You can use them so many other different ways. And if you look in the notes, there's like things like fill flood, pixel, which is what we're using, and there's transformation. So there's other things you can do with it. But this kind of gets you in the ballpark on how to do some of this stuff. And it's pretty simple, and it works very similar to LiveCode's image data. So fantastic. Well, thanks for joining me, and have fun making image filters with Sojo.